Hello students, welcome. Previously, lesson 14 from 4 topic 4, we were dealing with the first factor affecting the preferential discharge of ions during electrolysis, which was the position of the cations and also anions in the electrochemical series. So today, lesson 15, we want to proceed to the second factor affecting the preferential discharge of ions during electrolysis, which is the concentration of the ions in the electrolyte. And we are going to start by saying a cation or an ion whose concentration is high is preferentially discharged if the ions are close in the electrochemical series. So we are going to do examples, and our example 1 will be electrolysis of concentrated sodium chloride using graphite electrodes. So here we're saying concentrated sodium chloride solution contains sodium ions and chloride ions from sodium chloride, hydrogen ions and hydroxide ions from water. Remember, we are dealing with non-binary electrolyte and we are given concentrated sodium chloride. So we are going to have the sodium chloride, that's the ionic compound, decomposing to produce sodium ion and also chloride ions, and the water, which is also in the solution, ionizes to form hydrogen ion and also hydroxide ions. So in total, concentrated sodium chloride solution contains 4 ions. That is sodium ions, chloride ions from sodium chloride, hydrogen ions, and also hydroxide ions from water. So out of the 4, 2 are cations. That means sodium ions and also hydrogen ions are cations, while chloride ions and hydroxide ions are anions. So what will happen when an electric current is passed through the solution? We are told chloride ions and hydroxyl ions, being negatively charged anions, they migrate to the anode. That means the anode is the electrode which is connected to the positive terminal of the battery. So between chloride ions and also hydroxide ions, which one will be preferentially discharged? Remember, the solution that we are talking about is concentrated solution. That means the water in it is less. That means hydroxyl ions are few. That means chloride ions are the ones that are in a high concentration. Therefore, chloride ions are preferentially discharged, and the reason why we are preferentially discharging chloride ion is that due to their relatively high concentration compared to the hydroxide ions. So we are discharging chloride ions, not hydroxide ions. So we go and see the reaction at the anode. We are discharging chloride ions. So we're going to have 2 moles of chloride ions solution, losing 2 electrons to form chlorine gas. And remember, we said electron lost are written on the product side. So next, when we got about the cations, we are having sodium ions and also hydrogen ions. They are positively charged, the cations, so therefore they will be migrating towards the cathode, because the cathode is the electrode which is connected to the negative terminal of the battery. So now between sodium ions and hydrogen ions, which one will be preferentially discharged at the cathode? And we are saying here hydrogen ions are preferentially discharged as they have high tendency to gain electrons compared to sodium ions, in spite of their high concentration. Remember, when we were talking about down for the anode, we said chloride ions are preferentially discharged over hydroxyl ions, and the reason was due to their relatively high concentration. But when we're talking about the cathode, that means sodium ions are in a high concentration, but they are not preferentially discharged. Instead, hydrogen ions are preferentially discharged because they have high tendency to gain electrons compared to sodium ions. Remember, when we were talking about the note, we said the cations whose concentration is high is preferentially discharged if the ions are close in the electrochemical series. So the ions that we are talking about here are sodium ions and also hydrogen ions. So let's just try to see where sodium ions and hydrogen ions are placed in the electrochemical series, if they are close in the electrochemical series or if they are very far apart from the electrochemical series. So this is the electrochemical series. Sodium is here and also hydrogen is here. So that means they are not close in the electrochemical series. You have to know that. So for this reason, that means sodium ions will not be preferentially discharged in spite of their high concentration. Reaction at the cathode. So we're going to have 2 moles of hydrogen ion solution gaining 2 electron loss from the anode, and we are going to get hydrogen gas as our product. So next, we are going to go to the observation made at the anode and at the cathode. Remember, at the anode, we are having chlorine gas, or we have formed chlorine gas, so the observation will be bubbles of a green yellow gas is formed. Then at the cathode, remember, we have formed hydrogen gas. We are going to see bubbles of a colorless gas that distinguishes a burning splint with a boop sound is formed. So next, we are going to go and see the electrolytic cell. This is the electrolytic cell. We are going to have the cathode here, and the cathode is the electrode which is connected to the negative terminal of the battery. This is the anode electrode, and anode electrode is the electrode which is connected to the positive terminal of the battery. You have to do that. So when we are having electrolysis of sodium chloride solution, our electrolyte there is concentrated sodium chloride. Then we are going to form chlorine gas at the anode, and we are going to get hydrogen gas at the cathode. And the ratio of the volumes of the anode, or the volumes of the gas produced at the anode, is equal to the volume of the gas produced at the cathode, because the mole ratio of chlorine gas to ratio hydrogen gas was 1 to 1. So let's go to the last part, that is points to note. So we're saying the pH of the solution increases, and this is due to the formation of sodium hydroxide, which is alkaline. Remember, we were having 4 ions in concentrated sodium chloride. One was sodium ion, and the other one was chloride ions from sodium chloride. The other ones were hydrogen ion and also hydroxyl ions from the water. So remember, we said chloride ions are discharged at the anode, while hydrogen ions are discharged at the cathode. So what will remain in the electrolytic cell will be sodium ions and also hydroxyl ions. So when sodium combines with hydroxyl ions, we are going to form sodium hydroxide, which is an alkaline solution. Therefore, the pH of the solution will increase, because initially it was neutral, now it becomes a basic solution. The second point to note is that we are told a mixture of gases may be formed at the anode. Reason? This is because at the beginning, chloride ions are preferentially discharged due to their relatively high concentration to form chlorine gas. But after some time, when the concentration of chloride ions and hydroxyl ions at the anode are equal, we are told hydroxyl ions are preferentially discharged to produce oxygen gas. So that means after some time, a mixture of gases will be formed at the anode. That means chlorine gas and also oxygen gas may have been formed at the anode. Learners, that is the end of our class today. Thank you for watching.